What up, class? It's your boy, Coach Urban. We back at it, doing this math thing. I don't want to waste too much of your time, so let's go ahead and get to it. So last class period, we we reviewed over exponent properties. We talked about math spam. Just a quick review, math spam. Remember the M stands for multiply. Whenever we're multiplying, we add our exponents. Whenever you see division between like bases, you subtract the exponents. And whenever you have a power, you multiply the exponents. So let's review over these and let's go over a couple of harder examples for today. So the first thing we're going to go over today is a product of powers. Okay, product of powers means you're multiplying. Okay, and when you're multiplying your like bases, of course, we add our exponents. But that only applies to our exponents. Our coefficients, everything else stays the same, but our exponents are the only thing we add together. Everything else we treat like we normally do. So for the first part, we have -2 times 7. Those are regular numbers. If we're multiplying numbers, we treat them, we always multiply numbers up to this point. You stay multiplying those numbers. -2 times 7 is -14. And then for the like basis, a squared times a to the third, that's going to be a to the fifth. And then b times b, remember the invisible exponent is 1. So that would be b squared. So -14, a to the fifth, b squared. For the next one, same thing. These numbers, we've always multiplied numbers before. We're still going to multiply those. 12 times 2 is 24. R to the 12th times r to the -10th. We add those exponents, and that would be r to r squared. Next, with division. Okay, remember when we divide, we subtract our exponents. But same thing as we did before. Whenever you have your coefficients, your regular numbers, since it's division, I'm going to stay dividing those numbers. The mistake a lot of students have made in the past, whenever they see these, they subtract them because we subtract the exponents. But these numbers, I treat them like regular numbers. 27 divided by 9 ends up being 3. Then I look at my exponents. 5 minus 2 is 3, so it's x to the third. And 4 minus 3 is 1, so it's y or y to the first. Down the bottom, I do the same thing. 18 divided by 2 is 9. The h's, 4. I have a 4 on top and 2 on bottom. 4 minus 2 is 2, so h squared. And then I have j. That'll be my answer for that. Next, we're doing power of a power, okay? So you have an exponent outside of here, power to a power. So on those, remember you're multiplying. So looking at that example, let's go ahead and look at this. So I have the 5, and 1 is the exponent for this first 5. Then I have 2 is the exponent for x. The exponent for y is invisible, so it's 1. And then the exponent for z is 3. So now, again, think of this like you're distributing this 5 to all the exponents inside. So it'd be 5 times 1, and so that'd be 5 to the 5th. 5 times 2 would be x to the 10th. 5 times 1, y to the 5th. 5 times 3, z to the 15th. Next, 5 to the 5th. I need to simplify that. 5 to the 5th would end up being 3,125. I can simplify that. The rest of them I can't really simplify, so I'm just going to write them out. X to the 10th, y to the 5th, z to the 15th. So on the next part, here we have the 2. Remember, it applies to the x, but it also applies to the 7. 7 has an invisible exponent of 1. So it's going to be 2 times 1. So that's 7 squared. And then you have 2 times 3, and that's x to the 6th. Then I'm also going to have 1/2 times 8, and I have y to the 4th. So now I can simplify that. 7 squared, of course, would be 49. x to the 6, I can't simplify anymore, so I have x to the 6. You're also multiplying y to the 4th times that, so I'm just going to add on the y to the 4th at the end. The next part is for your rational exponent property. Remember, the rational exponent property means the rational exponent pretty much means it has a fraction as an exponent. So if we'll look at this, we kind of went over this before. Remember, we use T-bow for this, okay? So it's top in, bottom out. So that means my top number goes inside the radical. So that's a 1. I don't really have to put a 1 with the x. I can. And then the outside number would be the bottom number, which is 3. Top in, bottom out. Another way, of course, you could write that would just look like that without the 1 as an exponent, invisible 1. Going down to the next part. Okay, again, this x, know that this x has an invisible 1 right here. X has an invisible 1. So when I write this the other way, as a rational exponent, is x to the 1 over 2 because the top number went inside. So this is the top number. And then the bottom number went on the outside. So that was the bottom number. One last thing I'm going to go over real quick. I'm going to go over this example right here, okay, because it's very important. I know we've kind of talked about the invisible exponent and everything, but in this case, for a radical, when you think of square root is pretty much the opposite of squared, okay? So if there's not a number on the outside, you have to remember that this is a square root. So when I think squared, it's actually a 2, an invisible 2 on the outside. That only goes for the square root. So this actually would be the top number went on the inside. So this was my top number, which is 3. And then my bottom number is that invisible number on the outside, which in this case, this is a square root. When I take the square root of something, it's a 2. So keep that in mind for that. All right, next we're going to go over the negative exponent rule. Remember, I talked about being a sad exponent. When it's a sad exponent, we have to make it happy by moving it to the opposite side. So if it's on top and it's a sad exponent, I move it to the bottom. If it's on the bottom and it's a sad exponent, I move it to the top. So say, for instance, let's look at a couple examples right here. Notice the x squared on top. It's already happy. We're going to leave it on top. The y to the negative 3rd power is a sad exponent. That means I move it to the top and now becomes happy. Okay, so you really don't even have to write the fraction. You can just write it as x squared y cubed. Next example down at the bottom, I have the 2. That stays the same. It has a 1 as an exponent, so it's already happy. Z to the negative 5th. Z to the negative 5th. That's a sad exponent. I need to move it to the bottom to make it happy. So Z to the 5th. Now I moved it to the bottom. It becomes happy. Same thing with x to the negative 2. It's sad. So I want to move it to the top. Now it becomes happy. It's a happy exponent. So 2x squared on top, z to the 5th on bottom. Last thing, one of the easiest things we went over last class period was the zero exponent property. Remember, anything to the 0 power will be equal 1. We talked about the easier examples for to the 0 power is 1, 98,347,529,354 to the 0 power was 1. All right, so let's go over a couple of the examples adding on to that. So I have 1 plus negative 30 to the 0 power. So I have 1 plus negative 30 to the 0 power. Anything to the 0 power is just going to be 1. Remember that 0 applies to anything inside the parentheses. So negative 30 to the 0 power is just 1. So really I have 1 plus 1, which would equal 2. On this last problem down here, again, this 0 applies to everything in the parentheses. So all of this to the 0 power, it doesn't matter what's in here, it's all to the 0 power, which just changes it to a 1. So I really have 1 minus 25 in this case. So 1 minus 25 and 1 minus 25 is a negative 24. Y'all have a good day. Hope I made this a little easier, and I will see you next class period.